Now, given what we know about the role of all three of those players, the liver, the beta cells, and iron molecules, what similarities can we kind of connect all of these three? Okay, so this is what I came up with when I was looking at the role of the liver. I was interested in iron overload and kind of all of the inflammatory chaos that causes. So the liver is responsible for managing iron, right? It's repurposing it, recycling it, it's storing it. If you want to know where liver is going, or if you want to know where iron is going, check the liver. Iron itself, iron, the molecule, the mineral, is important in proper energy creation. Our mitochondria are iron rich because they need it in creating cellular energy. Insulin has a similarly important role in facilitating glucose uptake in order to allow for energy creation. And that's where I started to connect the dots, because, okay, the liver determines the availability of iron, which is very important in cellular energy. The pancreas determines the availability of insulin, which makes glucose available for cellular energy. Okay, so two very important factors in mitochondrial health, in the cell's ability to create energy. What could they possibly have in common, right? What are some ways that we can draw connections here that can play off of each other in the event that one of these is not able to do their job? So I'm looking for a deeper relationship. Now, shouldn't beta cells have a unique relationship with iron, right? Because beta cells are like the step number one in making energy possible. They're the ones opening the door for glucose to get into the cell. Now, once glucose gets into the cell, iron is one of the main dogs in the mitochondria, making glucose utilization possible for the cell to use the ATP from it. So I'm thinking there has to be some line of communication or some relationship between beta cells and iron utilization, because when a cell senses that insulin is here, that means it has to have iron at the ready for the newly delivered glucose to create energy, right? And okay, so you've got that unique relationship between the beta cells and the glucose. Well, the liver is what is ultimately determining the availability and the circulation of iron. So as someone with diabetes, I'm wondering, okay, so something happened at my beta cells where insulin is no longer being secreted. Structurally, genetically, the cells do not make insulin, right? There's something going on there where iron isn't able, or glucose isn't able to enter the cells. Now, this is just another demonstration of that trifecta that we talked about in the beginning. So if you know this podcast at all, we've talked a lot about how iron can influence the health of cells, especially in states of excess. Iron is very dangerous. Iron is very reactive when it is not properly bound. So, in a perfect triad here, iron is properly recycling and transporting via the liver. Liver is taking in those red blood cells, repurposing all of that iron. It stores what it needs to, in case of an emergency. and distributing what we eat as is needed. The pancreas senses glucose in the blood, releases insulin, making that glucose available to the cell for metabolism. The iron already in the mitochondria distributed from the liver is there to catalyze cellular respiration. Without it, mitochondria do not perform correctly. Now, we know that the liver and the pancreas have a connection in a healthy system, right? Regardless of what the dysfunction is, both in a healthy state, right? So that second dot here, glucagon secreted by the pancreas is what signals glycogen released by the liver. So alpha cells in the pancreas release glucagon. Glucagon goes to the liver and tells the liver to release glycogen to be the up to insulin's down, right? Every diabetic is familiar with the word glucagon. So we know that they are able to communicate. They need to communicate in a healthy system, right? Because those are the two main organs regulating blood sugar. And in a state of dysfunction, specifically iron overload, initially in the clinical states of hemochromatosis and thalassemia, in which the body is not able to properly process iron, the pancreas is a site where iron starts to accumulate in a way that is not healthy, right? So people with hemochromatosis are 50%, 50% of people who get hemochromatosis are going to develop diabetes. People with hemochromatosis have fibrotic tissue buildup in their pancreas. They are also insulin resistant, hence the development of diabetes. So we know that a dysfunctional liver that is unable to effectively manage its iron load, it has inadvertently affected the health of the pancreas, specifically the beta cells.